Ladies and gentlemen, friends and family, toonies, I come to you today with a heavy heart to pay homage to one of Flat Earthers, well, not one of their favorites, but one of Flat Earthers' most desperate attempts to explain why things go down. Incoherent Dielectric Acceleration, or I don't know, they call it by different names, but it has been through a few hard times lately, and much of it has been at the hands of Bryant Meyers, who is with me right now. So, Bryant, welcome.
It is sad, right? I mean, it was a good run. I mean, it was, while it was going, it was, to some, it was inspiring. To those that didn't see through the bad science, but it came to an end, to an unfortunate, fatal sort of observation. And I actually have the black swan here tonight. It's just a simple little observation that absolutely, it just kills it dead. And so we'll kind of get into that a little bit. Now, do you want me to be able to, can I share my screen? Can we put like a third?
Yeah. Go ahead and share, and I'll get it set up. And yeah, I had there were a couple drop frames. I had Dropbox was still running. I had to stop it. So go ahead and share, and then I'll set up the screen here.
Let's see here.
Yeah, Eric Erpelding is asking, could you, Bryant, define what is meant by incoherent dielectric acceleration? Well, it's something that not even the flat earthers who believe it causes downward acceleration really have a good explanation for, but we've tried to kind of pull out a few of the things that they've said. So, all right, are you able to share?
Is it? Hold on.
Is it letting you?
Just a little.
It looks like it should let you. So.
Hold on a second here.
Okay.
Apologies, I need to get a little more proficient here with Zoom.
So I'll explain while you do that. I'll try to explain a little bit. It's based on, so incoherent is like things have charge and they have neutral charge in general. But if you have something that causes the charges to kind of separate, so imagine a water molecule where there's a hydrogen and two hydrogens and an oxygen, right? And maybe the electrons from the hydrogen are more towards the oxygen side. Well, that means that that one side of the hydrogen, or so the water molecule, is slightly positively charged and the other side is slightly negatively charged. Kind of what I get from their incoherent idea, but of course that is evenly distributed because all of the water has got random angles to all of the different bits of the water. So there isn't a net positive side to a bucket of water, and there isn't a net negative side to a bucket of water. It's all just randomly distributed amongst it. So the net charge is still zero. So, okay, we've got...
Okay, we're almost there. I'm just trying to share this portion of my screen, and it's not.
Yeah, it's kind of zoomed in a little bit.
Let's see here. Wait. Here we go. I'd like to do this feature where you can just keep this one portion. That way it'll come on Zoom.
All right. Well, we're both working on the getting the.
We didn't have much time to set this up before.
Yeah, I was. If you weren't on I was on a different stream just before this, so I was a little bit with Gary Wybenga, by the way. If you're really interested, it was on Christopher Enoch's channel, and Gary Wybenga came in to share his claims.
I think we got it here, MC.
Yes.
Can you see the? Okay, so we got the.
Yeah, it looks good.
Now I did get some like last words from Whitsett before this is kind of his last comment, because I was trying to kind of get out of him. It's okay. Where does this 9.8? All the just to try to make sense of it. So, and like, how can it be super strong and then be super weak? How can it sometimes be attractive and then sometimes be no charge or negative or positive charge is charge and discharge, right? So there's like these 4 different explanations that he has. And so this is the last comment I got from it on YouTube. So he's saying there's a downward electric flow on the earth that sets the up and down. No one is claiming a giant force pulling things down to the earth. The downward bias sets the up and down. There is provably an electric flow down on the earth and it's very weak. Okay, now was I mishearing him when he said it's 10 to the 36 times stronger than gravity?
He did say that. Well, all right. So he said that the electrostatics in general is 10 to the 36 times more powerful than gravity.
Right.
And now he's saying that maybe this isn't electrostatics. Maybe he's saying this is electric flow.
Electric flow. Well, the gravity is kind of weak. So if he's going to use electricity or electrostatics to create gravity, it's got to be kind of weak then, right? Because if you're going to, it's kind of weird that he said it's so much stronger than gravity, yet he's trying to use it to explain gravity. So it's like, there's a little problem right off the bat with there. And so this is kind of the main thing. And I kept going back and forth with him with email debates, and he just can't, there's just nothing they can do to get 9.8 meters per second squared outputted from their model. I mean, they don't have a model. That's the problem, right?
Yeah.
And so all he had was these electric universe papers that you and I have kind of looked at, Morton Spears and others. And it's like, okay, they come up with a value for G, then you could say, okay, now we can calculate little g, but it assumes a spherical Earth.
Yeah.
So it doesn't help.
Yeah. So for people that don't know, Gleam and Atlas 6355 is mentioning this. Gleam, who is not a flat earther, he knows that the Earth is spherical, but he likes to LARP as a flat earther. He posted a whole bunch of electric universe papers on Whitsett's video. Whitsett sent them all to Bryant, but Whitsett did not read them. Not only it's one thing to read it and not understand it. He didn't even read them. But most of them agree that mass attracts mass, and they were different proposals for how mass attracting mass might have an underlying electrical component to them. Their hypotheses is what they are essentially. And none of them claimed that mass does not attract mass. They all affirm mass attracts mass. It was just about where it was derived from.
Yeah, and they all claim a spherical Earth too. None of those papers are going by the Earth being flat. And so now, just so that Whitsett, because he loves, you can see from this thing here, he loves the claim that I'm straw manning him. So can you play those video clips, everybody, just so he can't say that we're straw manning him? Because I want him in his own words to lay out his model. Yeah, so that way we can go through it and not put words into his mouth, right? We're going to use his words and his model.
All right, I will. Do we need to see? I don't know if we even need to see. But this is. That? Oh, all right. If you play it, it might come through. Then you can control it. Oh, but no, it's come. Oh no, wait. We see it here. All right, hold on.
Okay. So there's positive charge, potential charge. So.
All right. Did you hear that?
I heard it. Yeah.
Okay. Well, here we go.
So, what we actually see is that we have atmospheric electricity on the Earth. So we have an increase, equipotential increase. It goes up 100 volts per meter. Okay. So there's positive charge, potential charge increasing up from the surface, 100 volts per meter. Now, the only way that can be replicated or accomplished in any way, in any actual demonstration in the world, is you have to have two Gaussian surfaces. You have to have a surface above and a surface below to get that equipotential increase. It's the only way. There's no other way that can be demonstrated. So,
okay, so that was number one. So we're going to play by his rules. Okay, so we're actually going to go by his explanation, and we're going to it's going to be killed dead, even in their model. So we're going to assume that what he's saying is true, and we're going to show, and then we'll kind of add more things to it after that. But so can you play the next part? So this is the setup. So he's basically setting up. Can you still see my screen?
Yeah, yours is on right now. Yep.
Okay, so he's basically setting up this 100 volt per meter equipotential sort of increase in voltage, okay? And now the next little clip, he's going to talk about the downward bias. And this is where he mentions 9.8 meters per second. So if you could play that one now.
Flow of electricity on the Earth. So that's what gives you the downward bias. So when something fluctuates between 9.8 meters squared and 9.73, well, okay, because electrostatics is super weak. So the change in electrostatics would never be drastic. It's an agreed upon average.
What? I thought electrostatics was 10 to 39 times stronger.
Not all things go down. Sometimes things go up. So we can actually manipulate that variable. We can prove it's there. All matter has it. It's tangible. We can actually manipulate it in an experiment and prove that it causes things to go up or down.
All right, for those wondering, I was doing a live commentary, and so you're seeing my live commentary get added in. All right, go ahead, Bryant.
Yes, I mean, I just like your version better anyway. So now he's saying, okay, so from this gradient, there's a downward bias, and I couldn't get out of it. It's like, are you talking about just a one-way vector with no magnitude? That doesn't. I mean, if you're dealing with a 100 volt per meter electric field, that provably has a magnitude. I mean, you're using these numbers, right? You can't just say that it's a downward bias only. It sets, but then what causes things to go? Where does the 9.8 meters per second come from? He just says it's an agreed upon average, and
it's measured. It's not an average.
It's measured. I know
it's a measured average, not an agreed upon average.
So he just wants to kind of use that number and then plug it into all the equations on at least at sea level that we have in engineering and everything, and somehow that totally is fine with his model. Now the last part is, this is where the black swan comes in, the next clip you're going to play, because now he's going to admit that, I pinned him down during the debate. I said, okay, what's your F? Because we, with our model, I don't want to give it all away here yet, but with our model, we actually have an equation, and we can predict G at any altitude. We use the Cavendish to get the value for big G, right? And then we can use that, put that into Newton's laws, and we can calculate little G at any altitude, escape velocity and all this other thing. So, but even at sea level, we can at least have a derivation of G from our model. And he doesn't have that. So I pinned him down. I'm like, okay, what's your force equation? If it's not gravity, it's got to be Coulomb's law, right? Because this is, you're talking about an electrostatic gradient of 100 volts per meter. That is electrostatics. Electrostatics is governed by Coulomb's law. I mean, there's no Walter Lewin, the guy that you love to quote so much. He's got a lecture on electrostatics, and guess which equation Walter Lewin derives for us? Coulomb's law.
Coulomb's
law.
law.
Thanks for everybody's patience. I just wanted to do this so that everybody can hear that it's coming from his words, and I'm not straw manning him. So can you play the last little clip, and then we'll get in.
Yep, here it comes.
Force, that says F equals. So yeah, force equals mass times acceleration.
Okay, but again,
the acceleration.
Where are you getting that from electrostatics?
That's what everything is. It's literally all electrostatics.
Use Coulomb's law to derive that. Then, if you're using electrostatics,
we could use Coulomb's law, but it doesn't matter. The thing here is, my God.
That's what Walter Lewin, when he did his presentation on electrostatics, he derived Coulomb's law. That's the
Coulomb's law.
Electrostatics.
I know. Yeah, it's almost exactly the same as the gravitational law, but it's just charge is different.
That last part was priceless. He's saying because it looks like Newton's law of gravity with K, Q1, Q2 over R squared. He says it's the same, but yet he says it's 10 to the 36 times stronger, and it is. So you see the contradiction here. He's saying it's the same as gravity, but it really is 10 to the 36 times stronger. But now in this situation, somehow it's super weak. Somehow Coulomb's law has morphed into something that applies to atmospheric electricity that's totally not what we know Coulomb's law to be. So I just kind of want to come right in and just with the black swan. Let's not waste any time here. So with Whitsett basically, acknowledging that Coulomb's law, it's what we need for electrostatics. I mean, there's just no debate about that, right? So, well, actually, let me do these two figures here first, because it takes it through it more pictorially. So the problem here is that, the problem is that the gravity is when the acceleration due to gravity, the inertial mass cancels the gravitational mass. Actually, let me just show this right here real quick. So over here, we have, when we set F equals to ma equals to Newton's laws, we can kind of regroup it to ma, and here's our acceleration. And because inertial mass is equal to gravitational mass, and this is what led Einstein to general relativity, right? He realized the equivalence of these two masses and that they canceled out. And this gave rise to the curvature of space-time that he developed from this insight. And so because of this, the gravitational acceleration is constant at sea level because the masses cancel. Okay, now, now here's the black swan. Now with electrostatics, we do the same thing, okay? We set F equals to ma equals to QE. And for those that maybe don't know, QE, the electric force, is basically just Q or KQ over R squared. So it's basically the force per unit charge, just so simply.
K is a constant, Q is a charge.
K is a constant, Q is a charge. And the beauty of doing it in the electric field format is that you can just, it's like the sound of one hand clapping. You only need one charge, and from that comes the field, okay? So you don't need an action at a distance. The field formulation is also really nice in gravity, even before Einstein.
Yeah, and so to give a little background to people, Coulomb's law is about 2 points, 2-point charges, and then there's a field version of that. You can derive the field version of that. That's what we're looking at here. This Q times E.
And you're just dividing by Q. So essentially, it's Coulomb's law divided by Q. So just for clarity, this is Coulomb's law here. And because he's listing it as 100 volts per meter, that is an electric field. So it just kind of flows into this equation better than the expanded form of Coulomb's law, the 2 points. So when we do this, we set, then we solve for A. So we got F equals ma equals QE. So A equals Q over M times E. I hope everybody's following. And now, I
have to give some commentary on this. If you're not following, that this is saying that the acceleration is relative to the charge and inversely proportional to the mass.
Yep.
Okay.
exactly.
The
So
charge
we have
of the
our
object.
100. So even though the electric field is constant at 100 volts per meter, and oh, by the way, when you do all the units, it does come out to meters per second squared. When you use the K, it comes from the K constant.
Yeah.
You know, a lot of the units are, so you do get meters per second squared out of this because this is 100 volts per meter times Coulomb charge and divided by mass. So here's the thing, look over here, gravity constant because inertial mass cancels gravitational mass. Over here, there's no equivalent to an inertial charge canceling a gravitational charge. So you see the problem? So if we double the charge, we double the acceleration. So if you
change the polarity of the charge, you change the direction of the acceleration.
So I'll get to those pictures in a second. Okay. So now, but it's also mass doesn't go away either. So now you have also to divide by mass. So the only way you can get 9.8 meters per second squared is to fiddle with a charge and a mass that makes it work. But then it's going to be, it's not going to be the same for, so everything is going to have to be.
If the charge is the same for everything, then it's going to be based on the mass.
Yeah.
Which you'd have to have a very specific mass.
Yeah, a very specific mass. And but again, the point is they're not constants. Like you said, acceleration varies directly with the charge. So you literally double the charge, you double the acceleration. I mean, you double the mass, you half the acceleration. We're over here, we have this beautiful, smooth, constant acceleration across the surface of the Earth, 9.77 to 9.83. Over here, you just have chaos. If you use this equation, and just to kind of drive this home here, I drew this little chart. So if you had a positive charge, okay, things will go down. But again, if you double the charge, they're going to go down twice as fast. Again, using their model. And then you got mass in here too. So you got to draw your free body diagram, right? And you got to check, okay, so we got the we got the force due to electrostatics, and we got the gravitational. And this is what I can't get from them. They seem to believe that mass exists. Like I even asked Whitsett, that's like, okay, Whitsett, when you stand on a scale, that is mass, right? I mean, so you're not denying mass, but then if you don't deny mass, then it's got to somehow come into here. If that's where they're so confused, right? Because those electric universe papers were trying to equate mass or somehow mass attracting mass to charges within the masses, creating this force of gravity, right? So it's just so confused. But even if we take gravity out of, okay, I did this simpler version here. Let's just assume there's no gravity. Just turn gravity off. You're still going to have those same problems of doubling the charge.
That's their claim, of course.
Yeah. Okay, so again, but then when we step on a scale, again, I don't know what that means. I even asked Whitsett, it's like, okay, if there's no gravity and I stand on my scale, you're agreeing somehow that there is mass or density, right? They say density and buoyancy.
Yeah.
But how does that all fit in with this? But even if we just turn gravity,
they try to not say mass. For some reason, that's kind of the trend. They say density instead of mass, but density is just mass proportional to volume. It's still mass,
right? And Flat's right on that in that debate with FTF. I mean, he didn't seem to know what density was. They really don't seem to know what density even means. And so, but here's the thing: if we have a negative charge, now things will start to levitate. They'll go the other direction.
And it would not take a whole lot either. If there's no downward acceleration due to gravity, if it's at zero charge, right? If it's at net zero charge, it will neither go up nor down. It would just hover. And a small applied negative charge would cause it to go up right away. You don't need large amounts of negative charge. Small amounts of negative charge would make it happen because there's no additional downward acceleration, according to them.
So, I mean, right. So, and again, I kind of put this is both formulations of Coulomb's law here. So you got, this electric. So you can see. So yeah, I mean, you got these so you got these three possibilities. And the thing with gravity is it's always down. In fact, just kind of for fun here, these are just kind of evidence-based observations of gravity. So it's based on mass attracting mass. It's always attractive. There's no polarity, right? There's no. I mean, I know some people try to claim there's anti-gravity, like Whitsett and Dearth. With their little balloon, they like trying to show that this is It's not anti-gravity, guys. It's an electrostatic force you're playing with. It cannot. Well, we'll get to the cannot be shielded here in a minute. But it's a slow 1 over r squared drop off, which is spherical symmetry, by the way. Whenever you have a 1 over r squared law, that is coming from spherical symmetry. This is why, again, they're never going to get 9.8 meters per second to work because it comes from a spherical symmetry. And like I just said, it's the gravitational acceleration is constant at sea level. Oh, and this is something that kind of dawned on me, MC. You know how they have all those memes about Australia being upside down and they just keep going on and on about that? Well, if their electric field sets a downward bias, I mean, it's like, that's your version of up or down. I mean, you're calling it something different, but it's the same principle. It's like, why is it so hard to understand? But it has to do with our vestibular system registers only acceleration, right? We can't really feel it. We can't sense a constant velocity, and actually no meters can sense it either. So
it goes back to relativity. Constant velocity cannot independently be measured.
Yeah, can't be independently measured. There's no constant velocity meter. Even your car is using like the rim, whatever your rim speed on your tires or something.
The tire touches the road. That's how it gets that.
Yeah, it's not measuring the constant velocity. But anyway, so the up and down, it just comes from this gravity, this force, and it's like kind of silly. It's like, flat Earth, and you have this same downward bias. It's like, I guess that's setting of course they claim that it's just based on the fact that the Earth is flat, and somehow that just makes, but you're still going to have something that's going to tell your brain up and down. And again, it's very uniform. So to me, and this is playing by their rules, MC. We're given Whitsett his two Gaussian surfaces. He can have them. we're not going to even talk about how the electric field drops with altitude.
I want a disclaimer on that. Hold on. There is no need for two Gaussian surfaces.
No, there's
but
not.
Let's accept his hypothesis that there is two
Yeah.
Gaussian surfaces. It doesn't change anything.
It doesn't change. So we're playing in their world right now, and this still kills it dead. This is why to me, it's a black swan, because we're actually playing by their rules. We're living in their world using what Whitsett just said, and he can't claim a straw man because we just heard him say it. So
He said Coulomb's law. Yeah.
And he said Coulomb's law. I mean, he has to. If he's going to use 100 volts per meter, I mean, honestly, they're better off just saying heavenly energy, because it
leaves it vague.
It leaves it vague, right?
Their best hope is to never say anything testable.
I probably shouldn't have even said that. Now I probably gave
Now you gave it away. They're going to start saying they're going to give up.
It's going to be the ether. The next thing that's going to come along is going to be the ether and heavenly energy, so that we won't be able to do anything.
I mean, his Whitsett's Papa Flurf number 2 is Bob Nodell, and he says he have heavenly energies. So whatever.
Yeah. But this again, and forget that the dome. I just figured out after the debate actually that the second Gaussian surface was the dome, and forget that was short out because it touches the ground. I think it was actually one of your people left that comment. So I'm not going to claim that
wasn't me.
But,
yeah.
But
unless the dome is magically suspended and it doesn't touch somehow.
It doesn't touch. Yeah, somehow we're going to leave a little distance. But again,
flat earthers, make up your mind. Is there a dome? Is there not? Does it touch? Does it not touch? I mean, you should get together in it, like in a convention or something, and all agree on your story. Hey, this weekend you're getting together on a convention. Maybe you should have a session where it's like getting our story straight session.
Yeah, getting our story straight. So really, this to me is the black swan. I don't know if you saw the movie, but kind of a pretty good movie. So I mean, it's dead. I mean, this kills it dead, because it's going by their rules and it's playing by their game, and again, it absolutely is falsified. I mean, it's just can't. There's nowhere they can go from here. I mean, can anybody is there anybody in the comments that can maybe? Again, I'm happy to hear from even any flat earthers that are watching this. It's like, okay, where can we go from here? How can you resurrect this? I mean, how can we get the paddles out and bring it back to life?
Whitsett has been trying. I mean, he gave it mouth to mouth. He's been sitting and doing the chest pumping on this.
Yeah,
I mean, they're trying to get the electric paddles, the electrostatic paddles to.
Yeah,
it's not working. It's not working.
But see, now, if this is bad enough that you're dead, now I'm not a big fan of beating a dead horse, but as far as beating a dead flat Earth theory, now I'm all for that. But it actually still gets worse. I mean, it's this. Yeah. And actually, this is still playing by their rules. Okay, we're actually still in their world and their rules. Electric fields can be provably shielded. And again, remember in the debate, Whitsett said that you can get an electric field meter inside of a Faraday cage and it will say 0.
For clarity, Whitsett claimed that electrostatics cannot be shielded.
Yeah,
absolutely untrue.
Gravity cannot be shielded. So that's a fact. I mean, gravity is charge independent. I mean, it's actually the only way you can shield gravity would be a huge, massive shell of mass. And then you could maybe shield the gravity of a mass inside of that big, huge shell of mass. But here on Earth, we don't have anything like that to shield gravity. So gravity goes through everything. Gravity waves from LIGO went through the entire Earth all the way through. It doesn't get shielded. So this is something we know empirically. We can measure and we can see that nothing shields gravity. So this again is another way that it just kills it. I mean, electric fields can be shielded, and it actually comes from kind of a cool bit of science here. We need to use Coulomb's law, because this version of Coulomb's law is for like a vacuum or with the dielectric constant being 1, right? But in reality, the atmosphere is pretty close to 1. Air, you can see, so we can pretty much safely use that equation in the air. But in different materials that have different dielectric constants, the electric field gets shielded. So an dielectric constant of 50 would be 50 times shielding, right? Which is the human body, by the way, it shields electric fields about 50-fold. And it's because water has such a high dielectric constant.
So for reference, the D in incoherent dielectric acceleration, they say, and you're using the word dielectric as it shields electrical charges,
right,
and inside a capacitor, the generalized capacitor is two plates, and between those two plates is a dielectric material, or any material that has a certain dielectric property. And a vacuum has a dielectric constant of 1, and they don't use that in capacitors generally because it's not a very easy thing to make. So they usually put something between it. Sometimes it's in oil. Some of the old ones, an oil-soaked piece of paper.
Yeah, and again, the better the dielectric, the better it can keep the charges separated, because you don't want a leaky capacitor where the charges start to go from one side to the other. The whole point is to store energy across this gap. And so, I didn't think about that. Incoherent dielectric, just the word dielectric, that's a big part of, that's a big flaw in their model.
They're just throwing that word in because it sounds fancy. They're not using it in the way that dielectric actually is being used in actual work.
Yeah, this is the version of Coulomb's law in materials. So you can see this little E right here. So we have to we're just taking this equation, now we're dividing by the dielectric. So again, you can see the force with water, it would be diminished by 80-fold. And I guess human body is about a dielectric of 50, right? So electric fields, so if somehow this dielectric acceleration was based on electrostatics, then the outside of our body would getting more forces than the inside of our body, because it's getting shielded, and you have all this crazy things going on, right? It just leads to nonsense when you use that, trying to use it for gravity.
That would screw up our sense of balance.
Oh, everything. Yeah.
It's wow. I didn't think of that.
This came to me. I'm like, when I look back in my electrostatics courses, I'm like, wow, this is really bad for them. This is even worse than it was, because it just can't work. On so many levels. And metals. Guess what? Guess what the dielectric constant for a metal is? Infinity. Because electric fields inside of a conductor are 0. So now you have another problem.
Yeah.
And this is, by the way, why Faraday cages shield electric fields, right? Because it's the conductors. It's buffering because the dielectric is infinity. So a conductor will be shielding 100% electric fields.
So only the bottom layer of atoms on a hunk of metal, or maybe the top, or maybe the outside, would contribute to its downward weight. The entirety of the inside of a conducting metal would not contribute to its mass, or not its mass, its weight, its downward weight. So you could easily pick things up then of any size. It'd be delight.
Yeah, it'd be like a new buoyant force of sorts.
My goodness, people.
And so see, when you put a metal in an electric field, what's happening is that there's the free electron. So the positive side of that, the negative electrons go to the one side, and then the other. So you got all the electrons are grouped on the positive side, and then so it basically creates a net electric field of 0 inside the conductor. So this is another problem. It's like, well, we know gravity affects all these materials the same, and if you have magnets and metals and paramagnetic materials, they all interact differently with electric fields and magnetic fields. And then you have the magnetic field of the Earth still that's there, right? So, so anyway, this is a big problem. In fact, the whole dielectric and incoherent dielectric acceleration, it's a big part of their problem.
It's a filler word.
It's a filler word that is part of their demise. They're literally that's the worst. It's not helping their model by using that word. And again, I just kind of hinted at the different materials here are affected by our electric fields in different ways. The Lorentz force law, QV cross B. When you have an electric field and a magnetic field, magnets, if you drop a magnet electric field, there's going to be forces acting on it.
Yeah.
And if you accelerate a conductor through an electric field, then you got Faraday's law happening. When you got a changing electric field relative to the mass, you're going to induce little microcurrents, and you got some Lenz's law effects of resistances and things like that. I mean, all kinds of weird things are going on when you got these different materials. If it is all electrostatics, that is to say. So and so, by the way, this is still within their world. We still haven't gone into the real world yet. I mean, it still keeps getting worse. This is why it's a funeral, because we're kind of just getting warmed up here. So I don't know. Did you have any comments before we move on? So again, what we just dealt with was their world of, give them their two Gaussian surfaces, give them their 100 volts per meter constant. All of that, everything we just said applies to their world, and it still kills it dead. Everything we just said kills it dead.
We're applying their claims, right? They never work through it. We're working through it. We're just applying their claims, which is every time you apply the claims that flat earthers give, they don't apply their claims. They just have a vague idea of it and think that's it. But you go and actually apply it. When you actually apply perspective to the sunset, you find out the sun could never set due to perspective. But they don't know how to actually apply it. They say, well, you're doing it wrong. Well, what's the right way to do it? A different way. Which way? Don't know. So, all right, there's somebody in the chat here, I think, said what part of incoherent don't you understand? So I don't know if that was a flurf that's saying that somehow we don't understand the incoherent part of incoherent dielectric acceleration, or somebody just poking fun at the incoherency of flat earthers.
I think probably the latter. But again, I've heard Whitsett say incoherent magnetism to explain things, but it's like, wait a minute, Whitsett. I thought everything is electrostatics. Magnetism is not electrostatics. Magnetism comes from putting electric charges in motion. That's electrodynamics, right?
Yeah.
So by them saying everything's electrostatics, they're pretty much denying magnetism, because magnetism comes from moving charges. Literally, even in a magnet, it's from the spinning, like an iron, it's from the spinning electrons that are creating the magnetic fields. So all magnetic fields come from moving charges, not electrostatics. Another little problem with their model. And the fact that he's using incoherent magnetism, saying, oh, you don't know what incoherent magnetism is. It's like, well, wait a minute. I thought we were doing electrostatics here. Where did that come from? That's not, anyway.
It's not a defense of your position to say you don't understand and then insert something that doesn't actually have a meaning, right?
Yeah.
What is incoherent magnetism? Oh, you don't understand incoherent. Well, it's a made up term that doesn't actually have a strong meaning to it. So that's not my problem for not understanding it. You don't understand it either. It's just nothing.
Or if it's a real term, they pull it from some obscure study somewhere that someone said it, right? Then all of a sudden they think that they got some zinger on you, right? That's like, oh, wow, you didn't know that? And that's what Whitsett was going on about. I mean, I finally figured it out, MC. Just this long back and forth in the chat on my YouTube channel, all over the fact that he asked me in the first debate what a quantum liquid is, point blank. And I said, you mean like liquid helium? And he said, no. And he was coming from this liquid universe model of some, I don't know, some electric universe.
Some weird fringe idea that somebody proposed.
And I'm supposed to know his meaning of liquid, quantum liquid in that context. And then he claims that, anyway.
It's probably because he didn't actually understand what real liquid, quantum liquid is. He had only heard this fringe one. All right, let me read a couple things here from the audience. You want to stop your share, and then I can, they can see both of us.
Yeah. Yep, then we'll come back in.
So we've got Lael, who says, Brian, question. If incoherent dielectric acceleration is to rest in peace, will it finally reach its equilibrium?
I don't think it's incoherent. I don't think it ever will find its equilibrium.
Something about it's incoherent. Earth is Life. This is good. Earth is Life. He has a great channel. He says, I just stopped editing my next video for Whitsett to watch this. Well, maybe you'll have a couple. You'll be inspired.
Yeah, hopefully. I'm. I can't wait to see what their reaction is to this.
Oh, and Whitsett, his tactic is, well, you just don't blah blah. You're running away from it. I win.
Yeah,
It's
running away from it, and I kept pinning. It's like, just show me the paper. I'll look at it and tell you what quantum liquid. It's like,
Yeah.
anyway.
All right. Waikikamukow 855 says Professor Monkey for a Head is the greatest cartoon character ever. Changed my mind. I think that's to you. You're supposed to change his mind for who is the greatest cartoon character ever.
The greatest cartoon character ever. I mean, Bugs Bunny comes to mind because I'm a little old school. Something I grew up with.
I'm gonna go Pinky.
Oh, that's a good one too.
Pinky
Yeah.
in the brain. All right. Waikikamukow. Using Flurf logic, I just proved it.
Yeah.
You can't argue it. Stringer News 1 says, when Witless dies, game over will be on one side of his tombstone and thanks for playing on the other.
Oh. And doesn't he have some big experiment coming? Weren't you like telling me about some?
He said in the 24/7 Flat Earth Discord server, he said he's got some experiment that dogmatically follows the scientific process. And I don't know why we would care about dogmatic application of scientific process, because that's not our thing. We don't have dogma about science.
Yeah.
But yeah, that's other flat earthers have this dogma. Like if you don't follow it 1, 2, 3, 4 right down the line and the super, super narrow definition of it, then they throw it all out. It's just their attempt at science denialism.
Yeah. Yeah. So go ahead.
All right. I got a couple more. We got the C3P hole. It's a new member. See what you did there. As Negan says, hey MC, whatever happened to Kyle Adams? Did you get tired of his fake politeness? His calls for common ground seemed like underhanded tactics. Yeah. So Kyle Adams he's moved up. He is now one of the Globe Busters.
I heard, yeah.
It seems that the people that I debate have a tendency to make it to Globe Busters. So Austin, I debated him within 2 months. He was a Globe Buster. Kyle, I fished him out of. He had very few things. I don't know if he appeared anywhere with a non-flat earther before me, but I don't know. Maybe I'm launching their careers. But he's still on there, yes. But his fake politeness, his can we find common ground, is a tactic he picked up from Dearth.
Yeah.
And it's just a tactic to try to fool people. No, let's not search for common ground. Let's find where the things aren't the same. Yeah. And if they're empirically measurable, let's go with the one that's empirically measurable.
Yeah. So that's a pretty elite roster, right? The Globe Busters, like kind of like the Harlem Globetrotters, right? Well,
they're trying.
You got to have some real good tricks to be able to make it up to that league.
Yeah, I think so. Well, I don't know how the Morgile got up there. He doesn't have any tricks. If you don't know, the Morgile, he's got a little problem with drugs. I mean, a big problem, a really big problem. Anyway, he's always begging for money because he can't make rent. Because he smoked it. As this weekend, Friday, Saturday, Sunday, I think most of the Globe Busters will be in Greenville, South Carolina.
Yeah.
At the annual Flat Earth Global Convention.
A couple of them are speaking too. They're keynote speakers. They're like, I think they're pretty much, if you're a Globe Buster, you get to be a keynote speaker, I think.
Well, I could be. I didn't see Kyle on there, and Jaron's not a speaker. But you got Bob Nodell and Whitsett.
Is Jaron still a Globe Buster? I thought he went on his own.
No, he's still on the show with them. It's like,
okay.
It's like they don't have to all, like they bring in a bunch of people so that he can fill in the panel every week. With and then he'll Bob Nodell owns the Globe Busters channel, and he'll go have other people put together things so that to present. All right, hold on. We got a couple more. I got Dr. Nimrod, who's been a member for 5 months, says hello everybody. Holy wow, Batman, 5 months already. Thank you for that, Dr. Nimrod, for 5 months. The Sun Express says neutral, incoherent dielectric constants yeets absolutely nothing aboard my robot slave galleon cruising the high waters of Lake Titicaca. Arr. That was a difficult one to say.
Yeah.
All right. Lael says, do the other glob busters know Kyle is a Mormon? They probably do. Dirth comes from a Jewish heritage, to my knowledge. Morgile probably isn't all that real religious, being as drug stuff. Whitsett, Austin Whitsett is he has left what Christianity has gone into some Tanakh stuff. Jaren's not a Christian. I don't know about the others. So they're not really, Globebusters isn't really a very religious group. So
because they're kind of the hub for this incoherent dielectric acceleration, right? They're kind
that's
of
their thing, yeah.
That's their thing. That's kind of they're the main. They seem to me. You have a better pulse on the community than I do.
They've actually had what's his name? Ken Wheeler on their show. Ken Wheeler is not a flat earther, but he laughs at them. But he's been on their show. He's one of the Electric Universe guys, and of course he gets on and just talks. And unlike what you did, he never applies, the actual claims. He just makes these claims, and so best I can tell, all the incoherent dielectric acceleration stuff comes from him. But I would guess that he does not claim that mass does not attract mass, that he probably very much agrees that mass attracts mass. He's probably, with his IDA stuff, just assigning a different cause than the underlying, like what relativity does.
Yeah. Yeah. So you want to get into some more? You want to keep
I got one more from C3P Hole.
Okay. That's funny.
It says Whitsett is a cartoon character that uses mathematics. There you go. All right. Thank you for that. All right, let's go on. We can move on.
Okay, yeah. So so that's this part. That's Act 1. So just when you think it couldn't get any better, let me see here if I can.
You gonna share? There we go.
Oh, good. Okay, here we go.
That's a little bit too wide. I can't really see it. Can you zoom down? Zoom out on that? Because like the P in part 2, it's cropped. So if you move your cursor to the left, it shows it, but it's just a little bit too big. Maybe I can hold on. I'll see if I can make it bigger. And
so I'm putting the square around it. And it looks like it should be there.
All right, I got it now.
You got okay.
Yeah. So
okay. So now part 2. Now we're going to come to reality now, MC. We're actually going to come back to the real world a little bit, but we're going to do so with actual studies that prove that what we're not prove, but that give us evidence for what we're saying here. So now, when we get to the real world, what we find is that number one, the electric field is not constant. It does decrease very quickly with altitude. In fact, as we'll see, by 50 kilometers, about 31 miles, it's down into the millivolts per meter, and it's almost zero because it's a highly conductive. Remember what we said about conductors? Their electric field is zero, right? Yeah. So this kind of, it's a little bit below the ionosphere, but there's a very highly conductive layer of the atmosphere below the ionosphere. And so as these layers get more and more conductive, it turns out that electric field is falling off exponentially because the conductivity of the atmosphere is going up exponentially. So this totally does not match reality, because at 31 miles up, where the electric field is now zero, provably by atmospheric science, guess what the gravitational acceleration is at the 31 miles up? About 9.7.
Yeah,
it hardly dropped off at all. And it's because the 1 over r squared is big R, right?
And what was Whitsett's attempt at this?
He played some dodgeball there. I think that's when he started to ask me about rain, like how do clouds stay up in the sky or something.
Yeah, he kind of got off. I saw what he's trying to do there, because you said like at 30 miles high or something, right? And
Yeah,
he's
30
like,
miles high.
I don't claim that there is such a thing as 30 miles high.
Oh,
Or I don't even know what is there. Well, it's not, things have been that
you're
high.
right. You're right. He did say something, and I don't know. He told me at one point. I thought he told me at 50. They don't believe in it. I don't know the word is believe, but they don't kind of acknowledge anything beyond 50 miles up.
So they do acknowledge 30.
And that's what I'm saying. It's like, well, wait a minute. This is 30 miles up. This is not 50. So where do you draw the line? Where is it that we can't talk about reality anymore in your model? Is there some magic? I mean, I thought the dome was like 3,000 miles up or something, but they don't know. They don't know, right?
They don't know. Yeah. And Austin is of the I try not to make claims.
Okay.
But of course he makes lots of claims. He said 2 Gaussian surfaces are necessary. Well,
Yeah.
that's a claim. Where's that?
Yeah.
I'm sure he just heard it from somebody.
Well, but if he's going to acknowledge this 100 volt per meter electric field, the other Gaussian surface is at about 31 miles, because that's where the charges are. Because again, it's like a parallel plate capacitor, right? You know, the conductor, you got all the charges on the conductors, and you got like a dielectric in between. And now, you know, the atmosphere, it definitely is a leaky capacitor, right? Because we get lightning and there is a measurable current from the upper layer to the earth, right? It's just a very weak current.
Yeah, it's very weak.
And it's very, very weak, but it's like, well, your model is dependent upon this second Gaussian surface, to use his words. So you can't dismiss 31 miles up. And we can, this is again, we can see, you get accelerometer, gravitometer, whatever, you can measure these vibrations as you go up, and you can see, oh, this is dropping off by this very, very slow rate. And the electric field is dropping off exponentially. I mean, it is so wildly, just this, and again, there's even worse problems here as we'll go on. But where's the image I had of that here? Let's see. Well, anyway, let's just.
I think it's worth pointing out that it would reverse polarity at a storm. Now, Austin's defense of that was ridiculous. That's a letter E there in that. Yeah, this one as well.
I was going to get to that.
Okay.
I just wanted to look at the Carnegie study here a minute, because not only does the electric field drop by altitude, exponentially, but this Carnegie curve is very well validated. I mean, it's incredibly well researched. And it shows how the electric field will vary by 15% during the course of any given day everywhere on Earth. And it has to do with the whole, statistically, when lightning strikes the most during the dry times of day or whatever, there's a certain statistical thing that goes into this, but it's a very well mapped out curve. And it's also seasonal too, where the electric field changes by season. So remember, the electric field or the gravitational field in the Earth is changing by 0.7%. Oh, and this is something
across the entire surface of the Earth.
Again, they kept going on even after the debate. Whitsett kept emailing me saying, "Admit you were a liar about gravitational anomalies." I'm like, okay, Whitsett, I admitted that I wasn't aware of the rainwater studies on creating gravitational anomalies, but Walter Bislin, one of the smartest people I've come across online, he sent me this. And actually the anomaly due to the rain was much weaker than I even thought.
Yeah.
And so so he's going on about me not knowing about this. Look at how many decimal places here, due to the gravitational.
Down in the 10th decimal place.
No, this is an anomaly. I won't say that I didn't know about this, but Whitsett, it doesn't change my numbers at all. And even Bob on Goldbusters, if you rewatch that video replay, he kept going, Bryant, it does change. They're trying to make it sound like the weather is creating these wild fluctuations in gravity. If you go back and watch your replay and look at Bob from Goldbusters comments, he's making it sound like I made some fatal error in my presentation. And this fatal error is, look at how many decimal places.
So it's, I said 10, it's 7. But to be clear, this particular change is due to the mass of the water.
Yes.
The
That's what I
mass
kept
of the
telling-
water in the area around the gravimeter changed, causing this particular change. So it doesn't help you, Austin and Globebusters, because
Well, no.
it's a predicted change. It matches reality. You don't actually have a mechanism for why it changes down in that seventh position.
And I sent him the study that showed these numbers based on this calculation. And I said, Whitsett, if it's electrostatics that's causing these anomalies, show me a source. Show me your research. He sent me nothing. They're literally.
He sent you Gleam's papers is all he sent.
Well, but he didn't send me any proof about these atmospheric weather anomalies that basically he made it the way him and Bob, if you go back and watch the comments from Bob, it makes it sound like weather is like warping space and time in some really radical way. And that somehow I am way off in my numbers. And it really had me thinking, it's like, oh shoot, did I miss something here? And as soon as the debate was over, I'm like looking this up and I'm like, wait a minute, guys. This is, I didn't think it was as weak as what Walter sent me, but it was still very weak what I initially sent to Whitsett. And it's like, you're really making this big deal out of me not knowing about something that creates a change. So anyway, not to harp on about that, but the point is these are measured, geodesists. We know these anomalies are very carefully mapped out, right? The geoid variations, all these, and it is this very, very, very well documented. Here, I have it right here. The lowest gravity is in Nevada, this mountain here in Peru. Oh, I'm sorry. And then, this mountain in Peru, and the highest gravitational strength is in the surface of the Arctic Ocean. And they know this to 4 decimal places.
Those measurements probably are about 9 deep.
Okay.
Yeah, because the absolute gravimeters are 9 or more, and the relative gravimeters are about 9 decimals deep.
Oh wow!
So that's
figures. So geodesists have our gravity mapped very, very well.
Yes.
And so they try to use these gravitational anomalies like that's some big like they got this big secret weapon in their pocket. It's like, oh, you didn't know about gravitational anomalies, Bryant. It's like, well, maybe I didn't know about the one you mentioned, but it doesn't change the numbers I gave you through the debate. So of course, what we're talking about with the weather now. We're talking about exponential drops going up in the atmosphere.
Now, was this picture in one of Austin's citations? Wasn't it?
I'm not sure. Maybe I missed that, but he.
I could be wrong, but I seem to recall of a stream where he was on with other flat earthers and not you, and they had this particular.
Okay. I got to see what they have to say about this.
Which I love the irony, of course, but anyway, go ahead.
Yeah. So just kind of moving along here, this atmospheric electricity textbook is very validating what I'm saying. Even Richard Feynman in his wonderful chapter. By the way, it's free online. You can read Feynman's lectures on physics. There's a whole chapter on atmospheric electricity. And he knew, for his time, he knew an incredible amount about this that really hasn't changed a whole lot. They've learned new things, of course, but this more recent textbook talks about a similar, they actually list at 30 kilometers, it's already 300 millivolts. So that's even worse. That's like 18 miles up, right? Or 19 miles up. And it's already at 300 millivolts.
To be clear, that's a capital M, which usually would mean mega, but then in brackets, you see
over here.
Behind it. Yeah, SIC means it was their typing. They typed that, and the author who reposted it didn't correct their mistake.
Okay.
Should be a lowercase m instead of an uppercase m.
Yeah, that kind of caught me too off guard. It's like, is that 300 megavolts?
It's millivolts.
But it's milli. It's definitely milli because you can see over here the range.
Yeah.
And so again, exponential drop off. And so, let's get to the big one now. This is where it just kind of all goes off the rails totally. It's already off the rails, but this just totally annihilates their whole model. And so again, I couldn't understand Whitsett. Like, how in his mind you say downward bias, okay? And there's literally, anybody can Google it. Google how many lightning strikes a day. 8.6 million is what comes up. And I don't know why Whitsett was trying to get me to say that the whole field was flipping. I'm like, Whitsett, I'm not saying the whole electric field of the Earth is flipping. I'm saying that around each lightning strike,
it's
there's
localized.
a polarity reversal. It's a localized polarity reversal, right? And so not only is the field switching, well, not only is it going up by 100 to 150 fold, but it's flipping polarity. It's going the other direction.
So
I mean,
Austin's defense of this, his attempted defense was, oh no, I meant the field of the entire Earth, not just localized. But you can't do that. If it changes locally, it doesn't matter what's happening elsewhere at your location.
We can measure the electric field. If you're going to use 100 volts per meter, that's a measurable quantity.
Oh, but wait. Oh no, it gives the direct, it just gives the bias. It doesn't actually give the magnitude. Is where he went.
Well, then now
so it would
but then
slam you to the ceiling.
Doesn't help you to say that. I mean, you're whatever that just means that whatever the strength is that we're feeling due to gravity, now that same strength is turning around and going the other direction. If you take the magnitudes out, right, MC? I mean, let's just strip the magnitudes out, and we're just dealing with the vector only,
just
right?
the bias. Yeah.
It's just the bias. So whatever that bias is, it's taken a 180-degree turn and it's gone the other direction. So if we want to play the weather vane game where we're just going with an arrow and nothing more, then the whole weather vane just went from east to west or north to south, right? And so that means based on your logic that we should be levitating. And then, get this. Both Bob at Globebusters in the comments and Dearth both say, well, things do levitate around lightning strikes. They both said that.
Everything would. Everything. Not some things, not very light things that have already a charge on them. Yeah. Everything. And the more the more heavy something is when there's no lightning, right? The equally more heavy it would be to go up when there is lightning.
Yeah. And that should affect everything, not just charge. I mean, again, gravity is charge. We know this. It doesn't depend on charge.
Oh, look at this. Oh, all right. We got Flat Earth Dweller who's trying to defend this ridiculous idea. Says locality is irrelevant. The acceleration is caused by the electric charge from the firmament to the Earth. We'll accept that there is a measured inversion of that electric charge, Flat Earth Dweller. It doesn't help you to just lie about things. Locally, it changes.
But Whitsett, Dearth, Bob, they all use 100 volts per meter. That's not just a general heavenly energy expression. That's a very specific, technical, measurable term. So what he just said doesn't hold water here. Because your guys, and maybe he's got his own theory about this, maybe he's got a new theory, but this is not what the Globebusters are teaching. Globebusters is talking about 100 volts per meter. And again, that's measurable, and that turns around directions and increases by 100-fold. I'm sorry, but that doesn't cut it. I mean, again, they're the ones that said the 100 volt. Again, everybody heard Whitsett say it. He can't claim a straw man, right? See, I mean, this is what they're saying.
So here we go. Flat Earth Dweller comes back. The voltage difference charge is only very close to the lightning. Oh, so then that still doesn't help you, because during a lightning strike, things would fly up proportional to how much they go down. But of course, that lightning strike, assuming that, accepting your claim, right? Accepting your claim. Around the lightning strike, the things that have 100 pounds down would have 100 pounds up. Or if the magnitude of the charge generates the magnitude of the downward, then it wouldn't be a 100 pounds up during a lightning strike.
Guess what, Flat Earth Dweller? Lightning hit my house, and this is true. I was literally 6 feet away when it happened, and it knocked me back, and not up. I mean, it was more the shock wave from the sound wave coming from the strike.
Yeah.
I mean, I didn't fall over even, but I mean, it was sort of like this. But there was no gravitational effect, and I was 6 feet away from it. I kid you not, I'm not exaggerating. I was at my desk and the lightning hit the corner of the house and it totally blew out, like my Wi-Fi just exploded in the telephone line because the lightning hits the lowest ground and the lowest voltage part, right? And so it just exploded out. And it was pretty scary. That's never happened to me before, but there was no gravitational effects. And I was 6 feet away. So I was very much within that very high voltage polarity reversal. So I've experienced firsthand, and you don't know what you're talking about.
Well, to continue to make you cry, Flat Earth Dweller, inside of a Faraday cage, that whole charge is neutralized.
Yeah.
Things would float inside of a Faraday cage.
Yeah.
They don't.
But again, there's 8.6 million lightning strikes a day. And here's this little, so you can see from this chart here that the gravity is varying by 0.7%. The electric field, I don't care, even if it's in the localized area of the lightning, gravity doesn't vary in those areas. Gravity is, yeah.
You had a different one that showed that throughout the day it varies.
Oh yeah,
right?
This is the Carnegie curve. Yeah,
there you go. So the Carnegie curve shows that this 100 volts per meter varies throughout the day, flat earthers.
Yeah, yeah.
Okay, that's not, from the dome to the earth, and it's outside of this lightning idea. The weight of everything would vary proportionally to this change in it wouldn't
15%. Yeah, 15% plus or minus.
Yeah, it wouldn't cause you to fly up as it varies, but it would drastically change the weight. So to be clear, mass doesn't change, weight does throughout the day.
Yeah, you'd be weighing more like around dinner time, and then you lose weight in the morning. And it's a 15. This is not a small change, 15%. So the gravity, again, across the Earth, 0.7% differential from the Arctic to this mountain, right? And that's a big distance away. So you go anything that's a close distance is.
This is a good point. PhD Tony, who works with gravimeters, says that they shield gravity measurements in Faraday cages. So when they have these gravimeters that are 9 significant figures deep, they do it in an evacuated chamber. They do it with consistent temperature. They do it in a Faraday cage. There's a whole ton of controls that they do this, including Faraday cage. So if it's in a Faraday cage, a gravimeter would always read 0.
Yeah. Again, that alone, is you can't. Whitsett tries. Remember during the debate, he doubled down on it.
Yeah.
I kept saying it's like provably, Whitsett, electric fields can be shielded. You can get very, very expensive electric field meters that could measure. Inside a Faraday cage,
it's like your first week of an engineering class, right? Of electromagnetism. You cover that kind of stuff, right?
Yeah.
We both took those classes, right? And to say.
Right.
The absolute insanity to try to claim that a Faraday cage cannot do what a Faraday cage does. It shields
electric fields.
It fields electromagnetic fields as well. It's grounded. The whole outside is grounded. It's all at the same electrical potential. Oh my God.
Well, the fun fact about electromagnetic fields, like say your cell phone, it's the magnetic component mainly that's just getting detected. So when I used to do this little demonstration, put my cell phone in a Faraday cage, and the bars go down, but there's still something there. It's because the magnetic fields are harder to shield than electric fields. So electromagnetic waves, you got the magnetic component mainly coming through in those situations. But a pure electric field, and again, Whitsett very clearly says it's all electrostatics. He says everything's electrostatic. So that doesn't include magnetism by definition. And he still uses incoherent magnetism to explain the nuclear stuff, which I don't want to get. I did a whole video on this, and you posted it, so we don't necessarily need to get into the whole the whole nuclear. But that's another big problem with his whole electric model is he's trying to make the electrostatics cover everything. So not only does it have to cover the very weak force of gravity that extends out to the universe and kind of is the main on the larger scales, but also he's got to now use the same force to cover the nuclear force, which is now 100 times stronger than the electromagnetic force, right? And it's literally holding, within the quarks is holding these oppositely, or these same charge objects together when Coulomb's law said they should be flying apart. And what Whitsett doesn't seem to get is that the color charge in the electrochromodynamics is not at all the same thing as electric charge.
Yeah.
I mean, it couldn't be. I mean, it's in symmetry theory, it's a U1 symmetry, in group theory, it's a U1 symmetry in electromagnetism. The quark are the quark model is a SU3. So it's a totally, I mean, not to get into the details, but the structure of these forces, I mean, they're just so different. They do come together within the grand unifying theories at towards the beginning of the Big Bang.
Yeah, high energy.
At a certain point, the higher energy, eventually, and this is where the standard model is able to sort of, at a certain point, unify. But again, that's just incredibly high energies and the symmetry being broken so early on. I mean, what we have now is with the strong nuclear and electromagnetic force, they're very, very, very different forces. And again, Whitsett seems to think he's like, quarks have charge. Didn't you know that? It's like, yeah, Whitsett, during the debate, right? He's trying to say, you didn't know that quarks have charge? It's like, yes, they have charge. They also have mass. But then there's this new thing called strong nuclear force that you're just not getting.
Yeah. So Whitsett twice now, at least, has said that the nuclear force, the strong nuclear force, is charge-based. He doesn't really know anything about it.
Yeah.
It's not. It's QED or
the color
QCD.
chart, QCD, quantum chromodynamics. Yeah.
Yeah. And Feynman was the one that championed that. That's what keeps inside of a quark or inside of a proton and within the nucleus, that what keeps these things together that have differing charges. So they're different charges, they want to go apart, but the strong force is stronger and holds them together.
It's a very complicated, it's a very, I'm not going to pretend to be an expert on, quantum chromodynamics. I mean, I understand that, the conceptually I understand it, but it's a very, very, I mean, it's not easy type of, I mean, I guess conceptually you can get the gist of it, but it's a lot of group theory. It's like, it's basically, you got to understand really abstract algebra and group theory, but the point is that the color charge and the color force it's like gravity and it's a totally different force. I mean, it just has a totally different properties. And one of them, of course, is that it's attractive within certain ranges, right? And that it holds these like charges together in the proton, the neutron, and then it kind of seeps out and it holds the protons and the neutrons together in the nucleus, right? And that's through like virtual mesons and some other. It's pretty abstract stuff, but it's still kind of holding these charges together that Coulomb's law said should be flying apart at incredible forces, right? Because when you put like charges that close together, they're just going to fly apart in the other direction. Holding them together takes a tremendous force. So the whole, not to get too much into this, but it's a totally different force is the point.
But Whitsett thinks it's charge-based.
Whitsett, and he started to even throw, this is where he started to go into like incoherent magnetism, and he's like, everything's always attractive. And it's like, you're using electrostatics to define something that is not at all electrostatics.
Yeah.
But then he tries to use those electric universe papers try to equate charge and mass too, though. So they're basically trying to do this. Some of them are trying to kind of do the same thing. They're trying to make it all electric.
They're proposing it. So what do they have then? If they don't have a mathematical model, because you and I both know they don't do math. I mean, the farthest Whitsett got was F equals ma. Remember during the debate? Yeah, and he just wanted to swap G for A. That was the extent of his math.
G for A.
Yeah.
he did acknowledge Coulomb's law, but he wanted to change that subject very quickly. That's where he really started to squirm out and change.
You got nervous real quick.
Yeah, I think that's when we got into.
So here's a challenge to you, Whitsett. Do the math. You say it's Coulomb's law. You say it's electrostatics. These things are well understood. You claim to have the high IQ. You talk down to everybody else as if you are smarter. Well, if you are as smart as you claim you are, then you will easily do the math for all of these things. You said that in high school, you blew the curve out on some particular test. That was a math test. You said that the military specifically tried to recruit you, just like they try to recruit everybody, to come into the military because you were so smart. You have said on street corners across the country that your IQ is higher than all the other people that you were talking to. So Whitsett, use that super high IQ of yours to apply your claims. Coulomb's law, that's what governs the electrical attraction and repulsion between charges. That's what you claim it is. Show it.
Yeah, just show us. Give us a model from your model that outputs 9.8 meters per second squared. You can call it whatever you want, but it's a downward acceleration. Our model can do that. But again, he thinks it's just some kind of agreed upon average that we can just swap G for A. And but if they don't, again, you and I both know they don't want to have a model that can make any They never have a model that can make any predictions in the real world.
Then it's falsifiable, and they don't want that.
Yeah. So what do they got? So all they have left then is these silly little experiments or these observations from nature. So because they don't have math, because 1 over r squared is never going to work because that's spherical symmetry. So if they really do the math, MC, they're going to be forced to acknowledge the Earth is a sphere. I mean, that's the only conclusion by doing the math that you can come to. You can't get these numbers to work with a flat Earth because, as you and I know, the gravitational strength on the edges of a flat Earth would be going sideways to the middle center of mass. And you'd be like hanging from a cliff on the wall. If it was a gravitational, big, huge, massive gravitational disk on the wall, you'd be hanging off of a cliff because the center of mass would be a lot parallel to the center there. So you just get all these nonsensical things, like all the water in the world would be in this big pool in the middle, like this big, you'd get the trees bending. And I mean, it'd be like you're walking uphill.
It would be worse than that if it was just a disk and not an infinite plane or a very large plane, then it would just collapse into a sphere because it's bigger than the potato radius.
Collapse. Well, that's the whole point. Yeah, that's the whole point. It would collapse into a sphere. And but even like we talked about, even if somehow they get supporter beams to somehow keep it from collapsing, you're never going to get those numbers to work. But you're right. If you made it an infinite massive plane, there is a way that you can get the right mass to give you 9.8 meters per second in an infinite plane, but it will not decrease with altitude. It'll stay the same constant number because the drop off from an infinite plane is constant. There is no drop off because you can't escape an infinite plane because you got vectors coming in the higher you go up, right? So it turns out to be a constant. But we know it's not a constant. And none of the flat earthers claim to be on an infinite plane, do they? Or is there?
There is the Infinite Plane Society.
Oh,
IPS.
That's a new one.
Yeah, there are those. But to my knowledge, none of the infinite planers actually claim that gravity, they don't attempt to provide that as the explanation for gravity. They still go with all of the other nonsense about gravity. The infinite planers are the ones that could potentially offer that, but they still don't.
They actually could. They don't. They're in the best position to offer a 9.8. Now, it wouldn't drop off, but at least they could stay at the surface as 9.8 meters per second.
And it wouldn't vary by location or latitude or elevation. But
exactly.
I mean, it gives them step one.
It gives them step one. They can get a constant, which is a lot closer than where the current flat Earth models are at. So basically, what I was getting at here is because they have no math and no model, they resort to these little science experiments, or they just look at observations from nature, like spider ballooning. Bob loves that one, right? The bees attracting pollen, and they really think MC, that it's levitating up to the B. They
Yeah.
just seem to think that because there's only one force, right? It's got to be levitation because everything is electrostatics. And I just wanted to show a little clip here from Dirth, not with the sound or audio, but I just kind of want to explain what he's trying to do here. So what Dirth is doing in this little experiment is he's got this helium balloons, right? And this little button on the bottom. And they're adding a positive or a negative, doesn't matter, charge to this button. And it's pulling it down. So they think because they can manipulate, this is why they think their experiment proves that their model is right. Because they think they're manipulating the independent variable to cause the dependent variable, right? And they're able to manipulate this electric charge to make it go down. And somehow this is a proof that things go down based on their model. I kid you not.
They didn't control for the existing downward acceleration.
No, right. They didn't draw a free body diagram and see all the forces. There's a buoyant force going up. There's a button, some mass going down. But yes, when you add charge, you create an induced, it's a London dispersion force, right? You're inducing dipoles in the floor that's then attracting, it's a very weak, but when you got a Van der Graaf generator adding 40,000 volts or whatever it is, that's a very strong, it can create a strong
40,000 volts or whatever they were needing to apply for this to work is a ridiculously large voltage, which doesn't work with their model, because if it's, according to their model, a very small voltage would cause a large amount of acceleration.
They could have saved some money. The same principle was when you rub, I got a little wool thing here. I mean, if I rub the balloon with the wool, I can stick it to the wall, right? I mean, it's not hard. Anybody can do this with because you're just transferring charge to the balloon. So this is all they're doing is they're adding charge to that button, and the button's inducing a dipole and the going down. Well, guess what? If Dirth would have taken that button to the wall, it would have gone sideways. If he would have taken it to the ceiling, it would have gone up. It's nothing to do. It's just the proximity of the button to the floor that's inducing the dipole in the floor, right? I mean, I don't understand. They think this is such great proof. And one more. This is Dirth loves this one too. This aero electrodynamic thrust type of thing. So now what he says is now we're going to go in the other direction. Okay. So the first experiment was Dirth saying, look, we can prove that electromagnetic force makes things go down, right? Now I want to show you that we can also manipulate to make things levitate and go up. And it's not even electrostatics really, because it's doing. It's ionic wind, right? You're actually creating a corona discharge from the needles, and the air is getting pushed along with the electrons, and it pushes it up like a thrust.
The Dyson fan that's just a circle and has no blades in it. Yeah. That's what this is. That's what.
Oh, okay. I didn't realize that. But now then he's got the MIT one too, where MIT's got a really, and it's a cool technology where they can use ionic wind to create when they did their experiment, the plane didn't go very far, and they had to use 40,000 volts, right, to get it just because again, it's corona discharge. You're going from a thin electrode to a thicker one, and so the ions will, because of the high curvature, the ions shoot off the thin electrode, and then it'll attract to the thicker one, and that creates a flow, just like an airflow across a wing, right? But now you're creating airflow in a different way. You're creating it actually from the needles, and you're kind of forcing. So the lift that's created in these planes that MIT developed, it's similar to the lift in an airplane. It's just the airflow is coming from the ionic wind, from the corona discharge of the ions.
Oh, this is Ben D said that they don't work in a vacuum. That's a great thing.
Oh, right, exactly, yeah.
And that's
and
using
they won't work at high altitude. They don't work at high altitudes either, because you need a certain density of air for it to flow enough air, enough air to flow over it.
So you could put it in a chamber and evacuate half the air and half the pressure. It would start to affect.
But when they say that, when you hear these flat earthers say we can prove our model, this is their proofs that they're talking about.
Yeah.
And it's like, and I went through, if anybody wants to watch my last video, I did a whole video on flat earth science, quote unquote science. And I went through a lot of these things, and absolutely none of them prove their model at all. They just prove that our current science works.
Yeah.
And we actually understand all the forces that go on here. And flat earthers only seem to think there's one force acting on a body at a time. They can't seem to draw a free body diagram to save their life.
And for reference, a free body diagram It's just where you draw all of the forces and the directions that they're applying to an object. So the downward acceleration, gravity in our case, in their case, it's whatever. They don't quite have it defined well. But it's gravity, it's buoyancy, which works in the opposite direction. It's wind resistance if it's moving. It's electrical charges, just like that, right? Like they say, electrical charges is one of them. If they're not at the, but you don't need to include them normally unless you need lots of precision if they're small. So you wouldn't normally include electrical charge because it's going to be pretty deep in and probably much less than most measurements margin of error could even touch.
The thing with electrostatics is usually most electrostatics are on insulators, right? Because conductors, the charge is all kind of spread out.
Yes.
So insulators are better to hold electrostatics. So really electrostatics in our daily lives is like when you rub your feet on carpet or your dryer or your little balloon thing I just did. Of course, lightning is an example, but most things around us, I mean, I've got this little electrostatics meter. You can measure, most things are electrically neutral.
They don't have anything. Yeah.
Where is, like, if it is a negative charge and that would mean everything has to be, I didn't mention this. That would mean everything has to be positively charged. But then if everything's positively charged, attracted to the negative earth, that means that those positive charges repel. So we should all be repelling each other. And it's like just so many contradictions in their model, right?
They don't think to step two. They're like, step one. And then that's it.
This is not one or two, MC, this is not one or two problems we're going over here. This is like a baker's dozen at least. I mean, we've gone through
it goes on and on and on. It's the same problem. Many things on flat Earth, they offer one explanation, and then that explanation contradicts 10 other things, right? And I call them off diagonal, right? So they make a claim for here's a problem, here's the answer. Here's another problem, here's another answer, and that makes this diagonal problem answer, right? But every answer contradicts a handful of other answers, right? And so they have these off diagonal conflicts that happen, and they just ignore them. They can't think about them.
Yeah. No, and maybe that's a better way of saying kettle logic, so we don't get more fallacy things going. But it is kettle logic. I mean, in the way that fallacy is defined. But it's just so they resorting to these experiments, and I mean, I don't know, how are people just watching this and saying, "Oh, wow, that really does prove it." I mean,
because they're not that bright either, right? And this is the thing, Austin. You're not that smart, and the people that you fooled are less smart than you. That's how it works when you're fooling people, at least in that particular subject. Now, let me show. I have these. I have queued up Austin's boasting.
Okay.
Right.
Okay.
And I'll read them. I'm not sharing it to you. He said, "No, keep sharing your stuff. I'll just read it to you."
Okay.
He said right here, "My IQ literally towers yours, and you constantly call me stupid. You people are stupid, and I'm not partaking in circular stupidity. If any of you actually believe the claim your intellect towers mine, then STFU, and jump on my live and debate it. We can do it right now. I'm clearly smarter than you. I have over 150 IQ. What about you? Believe it or not, pal, the fact you don't like I'm smarter than you doesn't make you smarter. You know that, right? So maybe you should leave attacking my intellect out of this, eh?" And then finally, "I take cues from no one. I bet my IQ is minimal of 50 points higher than yours. So if I'm dumb, what's that say about you?" Well, thank you very much, Austin. You should then easily be able to provide the analysis that for these things that you say. Go ahead.
And
Let's see it.
Some actual real numbers, because 9.8 meters per second squared is a real number. And when you do these experiments, they prove absolutely nothing. You're not, how does this prove? They're so confident too that these things prove their model. I mean, and I just watched this. It's like, really? And I don't think most people know. I mean, again, this is maybe even the average person doesn't know London dispersion force. I mean, but I mean, it's not that advanced science to understand like how these charges are creating an induced dipole and what Durst's experiment's really doing. It's just the balloon. It's the same thing as a balloon. I've been transferring charge and sticking it to a wall. But these are not even like high school science fair worthy experiments. I mean, these would not win any high school science fair. They wouldn't even like.
You could do a middle school science fair project on making a balloon float by changing the voltage.
But have you seen any other? Maybe I'm missing some here. Have you seen any other like electrostatics experiments that they've done to try to show their model?
No, it's always the same stuff. Yeah,
and they do use the word prove. They do use the word prove. Suppose to them, and Austin. That's why in one of my videos I highlighted Austin's comments to me, and I underlined the word prove. Around these experiments, he used the word prove 5 times. So that means that, like you told me, that means it can't be falsified, which is, a Karl Popper maybe definition of pseudoscience, right? Or
yeah.
When you're making claims of proving something in the spirit of science that can't be falsified. What is that? That is pseudoscience, right?
The general demarcation between science and not science is falsifiability. It's too much for this particular video to go into that topic.
Too much. But he flat out said that these things prove it, right? And
I'm like, so as soon as you claim proof, you've exited science, and if it's posing as science, then it's not just non-science; it's actually pseudoscience.
Yeah. The most interesting of these experiments, the spider ballooning to me is kind of fascinating because this one had the most forces acting at once, because you did have there was a little electrostatic attraction of the negative charge on the web, right? That helps to carry it upwards.
Yeah.
But you also had like lift, like a lift force from the parachuting effect of the spider web. And then you had the drag force because the spiders have to be less than a milligram in weight. Otherwise it doesn't work. So, and then you also had, of course, gravity, right? So when you draw the free body diagram of spider ballooning, you got like at least 4 different forces acting on that. So when Bob does the analogy, when he explains it, he says it's all electrostatics in his explanation.
Yeah. So
at least when I watch
it, and they don't even begin to come close to anything in the realm that you might even propose as proof, according to them, because you didn't. You need to eliminate other things, right? Did they eliminate in these electrical things? Did they eliminate gravity? No, they just identified that something made it go up. Did they eliminate buoyancy? They didn't take that into account. They didn't know how much. They didn't do any of those things. All they did was, something went up, therefore proven. No.
Yeah.
If you look at the actual like published science that people do, the really good ones, they spend pages and pages and pages going over all of their effort that they put into controlling the conflating or confounding variables so that they know that what they're doing is actually what they're seeing, right? That it isn't something else messing with them.
Yeah. So this is kind of where, this is kind of the end of it. We can certainly open up to more questions here. Mm-hmm. And to me, it is a pretty, it's a pretty brutal death, actually. It's not just death by one cause. It's like, 13 or 14 fatal bullet wounds coming in from all directions, right? And I don't know, what can they say to all this?
They'll just show one more single experiment where it was essentially the same thing.
Yeah, just somehow manipulating electrostatics to create. Again, it's the electrostatic force they're playing with. And
ignore all other. Pretend that none of the other forces exist. Hand wave dismiss the many measurements of mass attracting mass. They won't even look at that.
Yeah.
They just hand wave that away.
Well, my hope is that people that are still on the fence that are watching this can just kind of take this in, and it's like just kind of soak it in and just really critically ponder what these guys are saying. It's like and just look at all the ways they're contradicting themselves, and not just one. I mean, in many different ways, right? I mean, they just like you saw in one of the videos I did, all those sound bites from Austin. I mean, in 4 different ways, he's contradicting what he's saying. You know, electrostatics is always weak. Electrostatics is 10 to the 36 times stronger than gravity. Electrostatics is neither positive nor negative. It's just charge and discharge. Then he says electrostatics is always attractive, you know, and it's like, and all of those claims, they all are contradicting each other in one or more ways, right? So that's kind of my hope.
Flat Earth Dweller just said, and here is the essence of a religious cult. Just said, I want to read it. Said, there is no evidence that mass attracts mass, period, and then lots of exclamation points. Sorry, denial is not refutation. mctoon.net/G has 18 measurements of the strength.
Good stuff, too.
The strength of mass-to-mass attraction. You did not do anything to refute them. You did not find flaws in their methodology. You didn't do anything at all to actually address the evidence for gravity. You've only made a religious claim. That's all you've done, Flat Earth Dweller. That doesn't establish the shape of the Earth. That doesn't establish whether or not gravity exists. All you've done is go to religion.
Yeah, and again, the evidence, as you've shown on your page, there's like 200 or 300 of those peer-reviewed studies with Cavendish or Cavendish-like experiments. I mean, I've got a Cavendish. I mean, not many people do, but I actually have a Cavendish device. I mean, you know, torsion balance, and you know, I've done the Cavendish, and I mean, I don't get incredible accuracy, but it's still really cool to see with your own 2 eyes mass attracting mass, and getting, even if I'm 2 or 3% off, I'm still getting a number that's really close to 6.67 times 10 to the minus 11. And it's like, if that was electrostatics or something else, it would be wildly off from that. It wouldn't, I mean, in the fact that they get the same number, and then the ones that are careful, like the ones you post on your site, they get it accurate out to 4, 5, 6 decimal places. I mean, or at least 4 or 5, right? Or maybe 6. But it's, you know, again, admittingly, it's not the most accurately measured of the constants, but it's also one of the most difficult to measure. Yeah. But those are all absolute empirical, solid evidences for mass attracting mass.
And the accuracy isn't necessarily that important when you're just answering the question of whether or not mass does attract mass. That's simple, true, false. When you've controlled for the other confounding variables, so that it's, you know, it's not electrostatics because they're at the same ground and it's in a Faraday cage, and you put it inside of a vacuum chamber, and you use non-magnetic materials, and you demagnetize the materials anyway.
Yeah.
Right. And
all those steps.
Yeah. Or there's some of them where they constantly change the orientation of the entire thing, so that if there's a wall that has too much mass over on one side, then when it's rotated 90 degrees, it will work in the opposite direction, and you get an average of all of those.
Right. Yeah. Right. Just careful. I mean, again, we went over this before, I think, in the debate we did in the post-debate interview. You did an example, and you went through a really good one too in that post-debate and little talk. Yeah, the BIPM.
If you go to mctoon.net/G and just search for BIPM, that particular one is amazingly detailed in all of the things that they did.
Yeah.
And here again, we have all of that stuff. We have Flat Earth Dweller saying, meh. That's it.
Well, I mean, again, you know, I do this to try to reach the people that are just still open, researching, looking, open-minded enough. The ones that are really deep in the trenches, I mean, well, who knows? I mean, some of them have come out. I mean, certainly. I mean, there have been like Ranty, right? There's been some that have switched to the globe. But when you're in deep, I mean, it seems difficult. But it's not impossible. I mean,
they didn't, for the most part, they didn't logic themselves into it. They're not going to logic themselves out of it. So, and Flat Earth Dweller says he's going to tear into those studies at some point, all 18 of them. Well, go right ahead.
I actually look forward to that. I look forward to him tearing into those studies and giving a detailed.
And I've seen them try before. They go into it, and instead of, because their claim is that mass does not attract mass. If that's the claim, then you don't need to go into a whole lot of stuff. You don't need to even understand the formulas that they're applying. You don't need to, you just need to look at that and answer the question, does this show that mass attracts mass? Yes or no?
Yeah.
So,
And again, I'm kind of tearing into some of their electric universe papers that they're sending me.
oh, there's
Those
some
are pretty easy to tear into. Some of them are just, I can't
Yeah.
even believe that they're published on some platforms, honestly. The
Well,
one I
there-
sent you today.
there's a wide range of journals that will, if a reputable journal won't take your stuff, you can go to a non-reputable one. And that's one of the problems with journals. And that's why Beale's list exists, to list the journals that will publish things without doing proper due diligence. Weiskopf says, can you guys talk about how you get constant numbers or whatever from Cavendish experiments? So how do we get constant numbers?
Well, basically, it's a torsion balance, right? So we're setting, so because we know that the force equation for a torsion, which is like a spring, but it's a rotational spring, right?
Yeah.
So we know that it's basically a simple, it's like F equals KX for a spring, only now it's the rotational version of that. So we take that force, and now we got the force, and because it's a torsion, it's going to be torques. So you have force of gravity times the distance, force times lever arm, right? Equals force times lever arm of the restoring force of the torsion. And what you do is that you measure the period of the swing after you put the masses, and that period you can use along with the displacement to find the spring constant K. And once you find the spring constant K, then you can set the force of gravity equal to the torsion force, and you can solve for big G. And
Welcome back.
It's more. There's more to it than that, but basically, because the way you're setting up the experiment of mass attracting mass, you can do it in different ways too. Like with the Mount Schehallien, it was also setting a different type of a force equal to a force. So in this case, it was the deflection of the plumb bob, and you could measure the angle of deflection, and you can calculate what that force would be needed to deflect that plumb bob, and set that force equal to Newton's force and solve for G that way. So the reason you're getting G in every single one of these cases is because G is the proportionality constant between the force of gravity and mass M1, M2 over R squared. So because it is mass attracting mass, you get the same proportionality constant whenever you do a very careful experiment. And again, there's more than just the Cavendish, there's different ways of doing it. But you're basically setting a known force a known force law that we can know and measure equal to the gravitational mass equals mass, because Isaac Newton didn't know what big G was. So he had to set the mass of the earth times G equal to force M over R, he had to work with ratios. So, because he didn't have the G, right? But he could still, even with the ratios, he could still make a lot of accurate predictions with the solar system. So it's really cool that, that when Cavendish in late 1798 or whatever came and he got within 1% with his, even though we've come a long way, it's still amazing that he got better precision than I can get when I do it myself, because he put a lot of care into measuring.
Well, yeah. And when you have larger test masses, then you can have more precision too. So let me show you this.
Yeah.
You'll have to watch don't change your sharing. You'll have to watch on the live stream
Yeah.
if you want to see it. But BM Furball set up, this is for you, Weiskopf, set up in his apartment in Korea, set up a torsion bar. And you can see there going across the screen horizontally, that's the bar. Those are the masses on the torsion bar. And that's being suspended from the ceiling. And they are right now at rest. And you can see a little bit of he put a mark on this thing at the bottom of it, and that's where this laser is. So there's a mirror that's on the torsion wire with the laser pointing at it, so that you can you can see small movements of the mirror.
It's a mirror.
Yeah, bring large movements in the reflected position of the laser. All right, so here it is. So here is, all right, so you can see the light there on the right of that black line that he added. And what he's doing now is he's moving from the other room. He has it's controlled remotely. He's moving the masses into place, the test masses into place you can see it's a 40-pound dumbbell, and each side is about 20 pounds actually, because it's cut in half, and then he removed the handle. So this is moving it close, and then what happens is it starts to oscillate, and over time, I'll play it here. You can see I'm going to speed it up. And so over time, you can see there it's moving to the left. You see that light moving to the left? That's the mirror moving. And the oscillation in this is it's not damped, right? It's allowed to go until it just comes to rest. And it takes a long time for it to come to rest.
You gotta wait it. From mine, I got a kind of a pre-made one, and I got to wait a couple hours before it comes to rest. But it's got a. But you do measure the period, because remember, periods are not. I mean, even with the pendulum, right? Even if the pendulum slows down, the period stays the same, based on the whole setup. So you're just measuring and you do need to measure that period, typically with a typical Cavendish type of a calculation. And then when it comes to rest, you can measure the displacement. Yeah. And then with the period and the displacement, you can calculate K, and then you can set the gravitational equations equal to the torques of the torsion balance, the restoring force, and you can solve for G.
Yeah. In this particular one, he was not seeking to measure the specific gravitational constant. He was just testing yes, no. Does mass attract mass? So then after this comes to rest after a couple days, is the light, the laser in a different spot? And then he moves it out of the way again and waits a couple days, and is the laser back to where it started? Yeah. That's what he was testing. So
nice. No, there's some good videos. Actually, the video, is that the one of that physics teacher online? I can't see your screen.
Yeah.
That's a really good demonstration that I think you shared that one, that physics teacher that did that experiment in his classroom, and he wasn't trying to calculate G either. He just was showing it's like really big with big lead. It was very visual. I'm like, wow. You could really see when you sped it up 30 times. Yeah. That you could see the mass moving back when you and I think you put a comment on his video. That's why I know. Oh, there's MC Toon commenting on your video there. Beautiful demonstration. Just a visual, just a very visual, without getting into the math. You can see mass attracting mass very visually. And by the way, in the comments, people were trying to debunk, I don't know if they were flat earthers, but trying to debunk the whole setup. And he gave very meticulous replies to those attempted debunks, that he electrically grounded it, that he talked about all the different things that he did to take into care all those, like you say, the confounding variables. Yep. But that's a good video to share, because it's just so visual without getting into all the math.
Yeah, it is. All right. So that's the yes, no, does mass attract mass? And he actually later, he removed this was fantastic. It was a surprise. I was watching it live when he did this, and it was amazing, right? The masses that he has on there are lead, right? Right. Those are lead masses, and lead is diamagnetic. It is repelled by a magnetic field. So he swapped out those 40-pound dumbbell weights with giant neodymium magnets. I almost couldn't say it. Swapped it out with neodymium magnets, and it repelled the lead instead of attracting it. So if people are like, well, it's because of magnetism. Well, he actually did use magnetism, and it repelled it, and it came to rest away from the magnets. And he's in a room there. It's not in a vacuum chamber, and it's not in a Faraday cage, but it is electrically grounded, so everything's at the same electrical potential. Yeah. But it's in a room. He covered the vents in the room, and the whole thing is surrounded by a plexiglass thing.
Right, because you're right. That's the thing. Lead is diamagnetic, so it would be repelling it. It's like you're not helping your case by trying to talk about that. You're going the other. It wouldn't be attracting you to go in the other direction.
Yeah, and so the only thing that things like that, if they didn't take into account, would to reduce the precision of their final numbers.
Yeah.
All right.
So
You're showing something here. All right. They can see what you're showing now.
Well, I was showing that when I was telling you about. This is just kind of a little GIF that it's not the whole video, but you can just see kind of the 50 times speeding up. You can really, if you watch it from how it starts slow. Okay, watch when it starts slow here. Well, this is he takes you from two different angles, and then you can see it just start to swing in.
Yeah.
Now this is not as noticeable when you do it at regular speed, but he's speeding it up 50 times to look at. You can just see that mass attracting mass so visually there.
Yeah. Yeah.
I mean, it's such a wonderful visual without even getting into calculating G, because it's not care. It's just mostly algebra, but this is just so simple, so visual. You can just see it. And again, there were people trying to debunk this setup, and he went through and you got beautiful explanations on all the things, all the care he took into doing this. And it's just, when you speed it up like that, it's just, wow, you can just see the mass attracting mass. And again, anybody that wants to take a little time and effort to set one of these up, if you're really interested in knowing the truth, I mean, take some time and investigate and do this yourself and see.
Yeah.
See if you can debunk it. See if you can show that it's wrong. Of course, obviously you got to
do it to your higher standard of evidence that you demand.
Yeah.
Right.
Exactly.
Since you don't trust it when we do it, you are the only one that you will trust for yourself, and you will have a higher standard of evidence. But when flat earthers have done it, they've, instead of using a torsion wire, they've used chains. I've seen flat earthers use chains. What's the torsion coefficient of a chain?
Yeah. Oh gosh, you can't
It's
even.
not going to twist.
There was this one guy that used all these. He took all this care in just the wire. So he did this experiment. He found all these different gauge of fishing lines. Then he used some metal wires, and he found the best. I mean, this is just to start. Before he even started the experiment, he was trying to get the right. I mean, this is the kind of care that, if you want to do this right, you get the right type of things, and you measure. You can see the periods. You want to find a very, typically you want a really thin wire, right? It's going to have some rotational stiffness to it in a sense.
Yeah.
And the thinness will give you it will help you to fine tune your results. Because if you use a chain, I mean, even if you use a thick wire or the wrong, I mean, it still makes it a lot harder to do, but a chain is not even, you're kidding, right? Are you joking that somebody used a chain?
No, a flat earther did it with a chain. Yeah.
Oh my God.
All right. So we have here, this is funny. Flat earth dweller. Just a little trash on you to dip on you here, to dunk on you. Flat earth dweller says, the compass points to Earth's magnetic pole in the center. Compasses actually can't work on a globe, he said. Well, compasses align to the field of the magnetic field of the Earth. They don't point towards the North Pole. They point north and south simultaneously. Yeah. I have right here a neodymium magnet inside of a globe, and you can see I've labeled north and south.
Oh, wow.
Now, flat earth dweller, are you watching? Because right here, look what I have. I have a compass. You said that compasses can't work on a globe. I have a globe and a compass. Guess what? It works. It works. You never tested it. I did. You were indoctrinated, flat earth dweller. You are showing right now how easy it is to indoctrinate you. Everything that matches your pre-selected conclusion, you accept without any critical analysis. And everything that contradicts it, you automatically reject, and then you search out ways to justify your rejection. That's dishonesty.
Yeah. And then a dip compass will measure the inclination, declination too, at a certain, once you get, and I think migratory birds use the inclination, declination sort of part of that in their ability to migrate. It's actually a really cool study on quantum entanglement and how birds migrate and how they will align up with the Earth's magnetic field, but they do so based on the latitude and the angle of declination, as well as, the north-south, because it's like a three-dimensional. It's really cool stuff, actually. It's a really cool study on quantum biology, or quantum mechanical effects in biological systems.
That's pretty cool. Well, unsurprisingly, Flat Earth Dweller changed and moved the goalposts, says compasses point north. No, they don't. A compass is a magnet. It points north and south at the same time. Then he said compasses don't work in Antarctica, which is a strange flex on your part, since you claim that nobody gets to go to Antarctica. You reject all information about Antarctica, but they certainly do work in Antarctica. The problem is that magnetic south is not even on the continent of Antarctica. It's in the ocean south of Australia. So they do work, and they match the magnetic declination that the globe predicts. So you're not helping yourself.
And apparently, Dirth's Flat Earth app also works in Antarctica too, by the way, because there are people from Antarctica that have logged in there. He didn't like when I brought that one up.
No. All right. That's not what I meant, clown. Compasses don't work in Antarctica. They do work in Antarctica. They work just fine in Antarctica. They match the magnetic declination. So anyway, I mean, kind of in conclusion, I mean, I look forward to flat earthers. It's like, listen, prove me wrong. Show me your model that can actually make predictions, and maybe I'll become a believer. I mean, but you know, I mean, again, this shouldn't be for some of the people that claim to be as smart as they are. I mean, it should not be hard to create a model that can just give you the acceleration at sea level, right? I mean, it's like, just give us that number for starters. Yeah, there's step one there, Austin, Mr. 150 IQ. But
not just switching A for G though. That doesn't. Yeah, you need cut it.
You need to, and it goes to what Feynman said. I'll get that up here in a second, but you need to compute the consequences of your hypothesis, right? Whatever your hypothesis is, that electrostatics, whatever, causes things to go down at 9.8 meters per second squared. Okay, now compute the consequences of that. Apply electrostatics, the laws that govern electrostatics, to it, and do the computed consequences of that match observation? Yes or no? And I know the answer to that, but Austin, you go right ahead and do the work and then present your findings. And an honest person, Austin, when shown to be wrong, will let it go and will move on to the right thing. My wife always talks to me. She says, you always think you have to be right. Well, yeah, exactly. As soon as I find out I'm wrong, I'm going to change my mind so I'm right again. I do always think I have to be right.
That's funny. But I mean, the problem, we kind of pointed out the problems that they're going to have when they try to do those calculations. I mean, very poignantly in this sort of live stream here. So they've got an uphill climb to get there. But I can't say it's an impossibility from what I've seen, but I just don't see how it's possible.
It's on them. It's on them to actually to do the work. And show that it actually works. So go ahead.
And I was thinking that a relative density disequilibrium funeral might be on the. Wouldn't be that hard. Yeah. that one probably wouldn't even take that long, actually.
Let's try to get them to explain it and produce a little more on it. Anyway.
That's right. They don't even have much of a.
They use the kinematic equations. And which is how you measure the downward acceleration. You use kinematics to measure the downward acceleration. So they don't actually, it doesn't work for them either, because when they try to output 9.8, the only way they do it is by taking previously measured, values with the kinematics equation.
And I was thinking about this. I actually looked up that the pressure during the course of a day can vary by a few percentages, certainly more than gravity varies. So, and we know if you go up in altitude, pressure goes down, and therefore density, things that are more dense should start going faster at higher altitudes, and they don't, right?
Yeah.
And And of course, I've got my cue ball and my lead ball right here. It's like, by their logic, a lead ball I mean, it's 7 times more dense. That's not like a close density. It's a lopsided density, right?
Yeah.
So that lead ball should be dropping a lot faster than the cue ball. They both don't have much air resistance, right?
Yeah, they have similar, if they're the same size.
But you can make a similar variation in atmospheric, like barometer readings during the course of a day, and that if they are using RDD, that those values for acceleration should be changing based on changing pressures. And it's certain, again, in a given location, gravity's not going to change. So this 0.7% differential doesn't apply to your location where you're standing. So having the barometric pressure changing in the course of the day,
but it's worse than that, because gravimeters are in an evacuated chamber. Pressure has no effect on it. It's the same everywhere.
All right. No, I'm just saying, going by just playing their game, right?
Yeah.
They're going to get variations that aren't there,
Storms, weather will cause.
Oh yeah.
Significant, percentage changes.
Oh yeah. Like the middle of a hurricane, you got a huge pressure drop in the middle. So anyway, you can kind of apply that logic to art. It's not as catastrophic though. I mean, with RDD, you don't have like these wild polarity reversals though, right? I mean,
yeah, you wouldn't get thrown up to the ceiling.
Yeah.
In a storm.
That's why I said the RDD's got less problems than the IDA, because at least you're not reversing 150 fold in the other direction.
Oh my gosh.
Anyway, funny.
All right, let me read a few things here. Shovelhead Steve, I love that name, says witless. Now I'm always careful. I don't myself substitute the obvious substitutions for Austin Whitsett. There are a few of them that present themselves. I don't feel I need to do that because he destroys himself. I don't need to swap in a different name. But I can enjoy a chuckle privately. Delco says you need to educate yourself before coming on stream. It's clearly explained with electromagnetic wake. You've not heard that.
Is that a Nathan Thompson?
Nathan Thompson.
Is that Nathan Thompson one?
Nathan Thompson got that from Bob Nodell, actually. So Nathan just repeated Bob Nodell in a debate with a PhD student in meteorology. When asked what causes hurricane rotation, he just said electromagnetic wake. I'm not doing the work for you. Do your own research. Which, of course, when you look up electromagnetic wake, nothing of the sort comes up. There's one paper that talks about it in a minute scale. It has nothing to do with hurricanes. He heard it, accepted it, and repeated it. Absolute indoctrination. Classic flat Earth indoctrination.
Well, what happened to that though? Since I've come on board here, I haven't heard anybody talk about electromagnetic wake.
It's their attempted escape for hurricane rotation. And that's specifically, I think Globebusters is really where you find that. I don't know if you find that elsewhere.
They've got some cutting edge science there, don't they? They just come up with a lot of stuff over there.
Well, all right. The video I have coming out Thursday, I've recorded it all and edited it. And I might even be in the final version of it, but it's for the Flat Earth Convention that's coming up this weekend. And it's just a giant piss take. I kept laughing the whole time. I kept laughing while recording it. I had to compose myself. And I told my wife, she's like, you just think you're funny, don't you? I'm like, well, yeah. Yeah. Maybe I'm not. People, you tell me if I don't, if it's not funny at all. But I did not pull punch. Anyway, I invented a couple of different sessions that people are teaching at. And I sent you the script. I don't know how much you've read of it, but I made like a graphic for it. Electromagnetic wake, the art of ad hoc excuses, taught by Bob Nodell.
Right. Yeah, it's like it's almost kind of exciting. It's like, well, like what's going to come out? They always have some new stuff coming out. Like, oh, I wonder what their new research is now. It's like it's all just words, right? It's just all explanations. But it's still kind of fun to to hear what they have to say, and then just kind of tear it to pieces, which is also kind of fun.
So I asked people on my Discord server and a few other places if they could say thanks, Bob, in different languages. That's in this video.
Oh, nice.
So, all right, I got a few more things to read here. Monkey Cat Pat Pat says you got to be an expert at word salad to flurf. He's been a member for 17 months. Thank you for that. I love Lord Illuminous Pooh. So funny. Says Whitsett never gets it. Well, he did a little bit with his now wife. She's due any day. Lael says, Dear Globebuster, if gravity does not exist, how can you have a gravitational anomaly?
That's a good one, actually. They claim it's electromagnetic.
So it's an electromagnetic, an electrostatic anomaly.
Electrostatic, yeah, it's electrostatic anomaly, right? That's how that's where they think those weather anomalies were coming from. They claim that it's electrostatic, but they couldn't provide me. I pressed Austin through several emails. Show me a study. I admitted to you that was not aware of weather anomalies to gravity. I said, okay, I didn't know that, but I'm interested. If you're claiming that it's electromagnetic or electrostatic, show me. And he didn't send me anything. They just see this in a paper somewhere, and they just
words,
jump. Yeah, it's like, well, lightning comes from clouds, therefore it's electrostatic. Like lightning's a part of weather, therefore I don't know what the train of thought is, but I could not find any electrostatic explanation or electromagnetic explanation for, and you're not going to, because gravity is a different force than electromagnetism.
I see Jiffy Cone says, now I know what you're thinking, but I have no idea how we're going to get a beaver to knit a sweater. I put Easter eggs in most of my videos, and he's referencing a Pinky in the Brain, and that's not on my list yet, so now it will be. Thank you for that. I have a list of Pinky in the Brain sayings, and that particular one wasn't on. I don't know if he said it or not, but it's definitely going to go on there. All right. Lord Illuminous Pooh comes back with a vegan, a CrossFitter, and a Linux user walk into a bar. It's the same guy. He just keeps telling us. I get that. How do you know if somebody's a vegan? They'll tell you.
They'll tell you. Yeah.
Steve6464 says, now that the sextant is dead, is IDA the next big flirf thing? I don't think it'll go. It's kind of a Globebusters centric idea. I haven't seen it much outside of there. I don't know, because it's their attempted explanation for downward acceleration. Oakley's crew and most of the ones on Discord and stuff, they're a relative density disequilibrium, and that's mostly the two camps. There's a couple others. The Flat Earth Society.
Oh yeah, the Flat Earth Society.
The Flat Earth Society proposes an upward acceleration, but there's hardly any of them that say that. So,
and it's the one that can get the number. I mean, the infinite plane at least can get you, and even if the disk goes crashing into the sun and the moon and all the other problems, it will give you at least it'll give you a 9.8 meters per second squared, as will an infinite plane. Those are the only two ways I know of that you can get 9.8 meters per second squared from a flat surface, either an infinite plane or a flying disk going straight up.
Oh, there's another.
Oh, is there?
Centrifugal.
Oh yeah. You're right.
Yeah.
Centrifugal.
If the entire Earth was on like a roller coaster in a circle and just going around and around and around.
Yeah, but then you got to have like a god or some deity like swinging the bucket or swinging the thing around, right?
There's no friction. It's a frictionless bearing.
Oh.
Some sort. I don't know. I don't know how. Maybe it's a.
Oh, but you're right. That could work. I mean,
I mean, there's a whole lot of other things that don't work with it, but
It won't give you it won't give you the variations for latitude or altitude, but at least you can get a 9.8 meters per second in probably those three ways. Maybe there's another way that we're not thinking about, but there's not many on a flat surface. There just isn't really many options to get 9.8 meters per second. There just isn't. So I don't know.
Right.
They got
let's see. All right. Lord Illum. Oh my goodness, I love these. Lord Illuminous Pooh says a Fitbit is just a modern Tamagotchi, except the cute creature you're keeping alive is you. Where are you getting these? He's looking them up. He's got a list. He's got to have a list. Waikikamukow 855 says, did I dream about a guy dressing as an alien and drugging people so he could probe them in certain areas, or did it really happen? I was almost on. They had to change the schedule, but I was almost on a podcast with somebody that claims that she was a real abductee. So it's to be scheduled at this point. Jeffrey Hollenbake says, Flat Earth Dweller, how is Bob's laser gyro affected by torque? Please explain. Yeah, Flat Earth Dweller, you ought to come on here sometime and present your super woke proofs. Yeah,
wait, who is Flat Earth Dweller? Is he a globebuster?
He's in the live chat. He's just seems like he mostly parrots things.
I was hoping to get some others in there. I only hearing you say his name as far as the
objection. There's a couple others, but CGI fan Dan is also here, but he mostly just copy paste and then never responds to things. So it's not as fun if they just copy paste and then copy paste a different topic and never respond. So at least Flat Earth Dweller's kind of interacting. He says Bob and Jaron were misrepresented on Behind the Curve. They have made videos debunking the misconceptions. Well, I understand, Flat Earth Dweller, that they claimed that. But outside of Bob's fiber optic gyroscope, there are many other fiber optic gyroscopes that have been used successfully to measure the rotation of the Earth. Bob's attempt at falsification, he misused the instrument and found that there was an instrument error. Oh no. You break an instrument, it's not going to give you the right error, or you misuse it outside of how it's designed to be used. Whoop-de-doo. That didn't show that the Earth wasn't spinning. That showed that the instrument wasn't used correctly. And Jaron, well, I don't know if he actually did make a video, but other cases have measured the curvature of the Earth. So it doesn't matter. They're not scientists. I will always go to people that have done much better measurements than they have, but it's funny that they just.
Well, I told you before with Jaronism, I told you this before that the laser he used, that it diverged too much with the distance. If he would have did a little bit of math, he could have figured out that was not going to work in the first place. This is an example where
he didn't use the laser in the end at all. He just used a light.
No. But didn't he at first try to do it with laser? Then he had to adjust it to a light.
Yeah, and he did. He poked holes in a board. Which kind of works, right? Because then it limits so that you can't have the large cone that it's going to produce is going to get chopped by the board. Which is, I don't actually have a whole lot. I mean, there's maybe some issues, but I don't have a lot of issues with the methodology of the test that he did.
But he talked himself out of the conclusion, though. He had his excuses for why it went.
It was
higher than
interesting.
Yeah, that was classic.
Waikikamukow says, okay, it's true. A man from Texas used special effects, drugs, and an alien costume to abduct and probe 79 people. Oh, that's a weird thing to want to do. All right. Stringer News 1, Austin says, 'tis but a scratch. All of these.
Who said that?
Austin says, 'tis but a scratch.
Oh, okay.
I'm invincible. I've had worse. Hunter says, Flurfs suffer from cranial rectal inversion. They should see a doctor about that. Raza 43 is a new member. at Newton level. Thank you for that. Glad to have you. And then Lord Illuminous Pooh says, if aliens don't exist, then who abducted me to a room full of flashing lights and probed my bum? Oh, the guy that ran the roller rink? I blocked that one. I'm sorry that you had that experience.
It is but a scratch, but it's got like lethal poison in the scratch, right?
Oh, poor Austin. I like this. Some say that Enrique is still standing there with the light to this very day.
When's it going to become flat?
Oh, poor Jaren. Well, I do. I don't know. I thought this video that I have coming up is pretty funny. I take a
I look forward to seeing it. That
I
should
take
be some
them all
good
over the
stuff.
place. I've messed with them. Anyway, it's been 2 hours. I think we have covered all of these things. And so, Austin, this is the challenge to you and your high IQ claims. Show how this works. Put pencil to paper.
Yes.
Take your claims and apply your claims. Coulomb's law is well understood. There's not a whole lot of magic to it. All of the millions or billions of devices that have been invented and built that rely on understanding of electrostatics. If you disagree with the state-of-the-art understanding of electrostatics, then it's on you to show how it actually works with empirical evidence. But all you have so far, Austin, are claims with no application and no computing of the consequences of your hypotheses. You are not willing to test them, or they are untestable assertions. If that's the case, they're pseudoscience. If you're unwilling to test them, we know why. So show us, Austin.
Yeah.
Don't show us a paper. Don't show us some electrodynamic or electric universe thing. You say the downward acceleration is due to this. You need to output 9.8 meters per second squared.
Yep. Pencil to paper. I like that. It just really got to give us enough, show us how it's done. Yeah. F equals ma doesn't cut it. You have to have a force equation on the other side to say what is causing the acceleration. What is it that is causing that acceleration? It's the
your task, should you choose to accept it, is to explain to us how the A came to be 9.8 meters per second squared. We can do that. We output, using gravity, 9.8 meters per second squared.
That is Mission Impossible, by the way.
It is. Your task is not to attempt to address why you don't think ours is correct. Your task is to show how yours is correct. Right? If you want, you go right ahead and attempt. 18 papers, mctoon.net/G. You find the specific error in those methodologies. You go right ahead. Get yourself a Nobel Prize by publishing those things.
And if you're going to just do those little electrostatics experiments, again, pencil to paper, show us where your experiment is giving us this downward number that we can all measure. So you can't just make something float with electrostatics or make it sink and think that that's somehow proving your model. You need to give us an output of how that experiment you're doing is showing the downward acceleration of 9.8, at sea level, right? And again, they just think those experiments are somehow proof that, look, electrostatics, therefore our model is electrostatics is true. That's not how it's done. That's not like at all. It's just missing the boat on what science is.
Yeah. Anyway, people,
Anyway,
thank you.
fun.
Thank you, everybody. Thank you to Bryant. If you have not subscribed to him, could some mod grab and post his link in the chat here? I'll add it to the description. Where you're at 700 subscribers?
Yeah, well, 750 now. I got some
Awesome.
YouTube unlocked something new for me to play with. So I got to 750 as some
Awesome.
threshold. I appreciate all your support because it's largely due to your help and support that I've gotten a lot of people. So, and thank you guys. I got more videos coming. So definitely like and subscribe. So it should be, we'll keep interacting and keep, until we'll see whatever they come up. We'll see what comes out of this. I'm kind of eager to see what.
Yeah. All right, Brian, don't hang up after I do the
Yeah, okay,
outro
yeah,
here.
yeah.
But everybody from home, everybody that watched, thank you very much. Thank you to super chats and members and patrons. I really appreciate it. It makes what I do here possible. So I don't have to go drive Lyft or any crap like that. So, all right, everybody, we will see you next week. And I have Weiskopf and the guy, I forgot his name. Two of them booked for next week. So it should be fun. Both of these guys are very different. I think very different. So I'm looking forward to it. So, all right, people, we'll see you next time. Bye.
All right.